All right, hey everybody. Today I want to talk about and share what I've been doing with stereophotography. It's something I've been interested in as a kid, and now that I'm doing maker stuff, I wanted to play around with it and do some of my own stuff. Stereophotography is actually quite old. This camera is from like 1890 or so. To take a stereo picture, it's simply two cameras that take the same image from slightly separate vantage points. So here in this camera, it's just two camera lenses separated by probably about 5 or 6 centimeters. That generates and creates two images. You print them out and they look like this. It's very difficult in this particular one to see the difference between the two photographs. But if you look very closely, in this image here, the woman's face is right on the shoreline, right at the breaking waves. And in this one, her face is a little bit further away from that point. And there's other subtle changes that you can see between the two photographs. To view the image, people would use a viewer. Here's the desktop model. They came out with portable ones, handheld little viewer models. You take the card, stick it in the viewer, and from the magnifying lenses here, you look at the card and the left eye will only see the left image and the right eye will only see the right image, and your brain melds those two together and you see a much exaggerated depth of field. In the original photograph, you can tell what's in the foreground and what's in the background. So in some sense, there is 3 dimensions to the photograph. But when you view it through the viewer, it's a stunning effect. The modern day version of that viewer is something like the Viewmaster. They've changed from cards to reels, where there are 7 left-right pairs opposite each other on the disc. And this lever here, when you pull it down, it will spin the disc inside the viewer and show you the next pair of images. And I had one as a kid, loved it. Wish I had it still today, but I don't, long gone. You can get the same effect without any hardware at all. There's 2 ways to do it, one called parallel and the other called cross-eyed, where one eye, both eyes, look off into infinity. They look off into the horizon, but you focus the lens on the photograph that's near to you. And that's a little bit weird. That's not how the human vision typically will work. If you look at the horizon, your lenses adjust to keep the horizon in focus. And in this, we want to look at the horizon, but focus on something close. And it takes a little bit of practice and a little bit of effort. Cross-eyed is similar, except that you cross your eyes. The right eye would look at the left image and the left eye would look at the right image. They blend together, you have to focus them, and you can see the effect, but it's tiring on the eyes. It's a lot of effort, and it's great for onesie twosies, but I wouldn't make a date night of it. In something like this, this photograph, it also has depth information there. You can tell that this pink petal is in front of the woman. There's me, there's the petal, and there's the woman. There's that depth information. How do I know? Well, I see some shadow there. I know that colors are blocked by things in front of it, and that's what's happening here with the green dress being blocked by the pink flower. I know that the toe is closer to me than the heel. So there's depth information there. But what about all these things? Where do they sit in 3D space? It's not at all clear. You don't have those visual clues. But with the appropriate photography, you can actually get that image to show you that depth. And now it's much clearer where in space these petals are in relationship to the woman, as well as the woman and this wall and the trees and all the rest around that. What's happening here, it's a left and right image, but within a single frame, and it's alternating quickly back and forth between one and the other, probably about 1/10 of a second between frames. And that's enough to provide you with a lot of depth information. And it really stands out much more strikingly. And that's what I wanted to do. I wanted to create a stereo camera rig that would generate photographs like this. Well, one way to do that is simply buy a couple of cameras and put them next to each other. Even with the Raspberry Pi, I didn't want to do it. It's 2 cameras, 6 cables, power supplies, all the rest of that. And I still needed a rig to set it up on. I didn't want to go that route. I wanted a single camera that could take multiple stereo images and then display them. So as I thought about it, how would I put that together? How would I design that? I thought about what a human or Mr. Pumpkinhead here would want to do. There's a scene that he wants to view in 3D. Right between his eyes, I've got a camera. And that camera is aimed at some point in space that I want to be the point of interest. And then to do the stereophotography, I'd simply move the camera to where his eye would be. But then I also have to change where the camera is pointing so that it points to that point of interest within 3D space. And then I take this photograph, move the camera to the other eye, pan it so that again, it's pointing to that point of interest. And now I'll take a picture and now I've got the left and the right images and I combine them. So this is what I came up with in terms of a rig that would do this. The green part here is just a housing, just a scaffolding to hold all the rest of the pieces in place. The orange here is a 28 BYJ stepper motor driven by an Arduino. The beige gear here is affixed to the shaft of the motor. As the motor turns, the gear will turn. That gear meshes with this linear rack. As the gear turns, the rack will either be pushed to the left or pulled to the right. The rack sits on this red platform, and it's here on this red part that I plan to put a camera. But I can't just stick a camera on there because I have to be able to adjust where that camera is pointing for the left and the right eye. So I got a pan tilt platform from Adafruit. There are 2 servos in here. One in the bottom here will control the pan. The other servo at the top will control the tilt, and the camera will fit here in this platform. Right now, this platform is at 0 degrees. The camera will lay flat against this surface, and in this configuration, it will point straight up to the sky. If you throw the switch and you switch over from 0 degrees to 180 degrees, the platform will pivot on this pivot point here and flip around, and the camera will point down to the ground. So for my purposes, I generally simply had it at 90 degrees, and the camera would simply point straight ahead. But the pan would be adjusted for the left and right. That's what really got all the exercise in this configuration. And it also is being driven by the Arduino. I find the Arduino is far better at driving these little servos than the Raspberry Pi is. And that's why I'm using Arduino in the first place. So here's the actual setup and how I go about actually taking photographs this way. I position the rack so that the center of the rack lines up with the spindle of the motor. And I have the camera on the platform, and I point the camera to whatever the center of interest is going to be. Turn on the Arduino, let all the code run, and the first thing it'll do is push out the actuator to the camera, and then the pan servo would adjust the pointing of the camera so that, again, the camera is pointing to that area of of interest. Let it sit there for a second or two, dampen out any vibrations, and hit a key on the Raspberry Pi camera and take an image there. Then the motor would reverse, go to the opposite side of center, again, panning the camera so that it focuses on that point of interest. Take a picture, and when I've got two pictures that I like, a left and a right, I import them into iMovie. I drag the two images into the timeline. I set the time between the images to be 0.1 second, and then I duplicate those pairs as many times as I want for as long as I want the movie to run. And this is the result. There's the camera, 20 times speed. As it shifts left and right, I'm taking pictures. And this is the final image that looked best. And sure enough, there's an incredible amount of depth information there. So I was successful in my test, but I do have some issues. One is the interocular distance. If you read all the how-tos on this, they say to move the camera about 5 centimeters. Where'd that number come up with? Well, if you measure the distance between your pupils, it's about 5 centimeters. Mine's 5.6. But I discovered when I moved the camera that much, the motion of the image, of all the things in the image, was just too wild and chaotic and jerky, and I just didn't like it. So I ended up going to more like 3 centimeters. I'm sorry, 3 millimeters. No, 3 centimeters, 30 millimeters. That was a much smoother effect. Also, how much to pan the cameras as I was moving back and forth. Maybe I don't even need to do that at all. Maybe I can just always point them straight ahead and just move the camera left and right. I need to experiment. I need to do a lot more pictures and play around. Things like, how close should the camera be to the image? Should it be further away? Would you get a more pleasing, less jarring effect? I need to do all those things now. Other issue is gear rack design. I knew I had to slide the camera left and right. I had no idea how I was going to do that. I figured I'd need a motor of some sort, but I didn't know how to get that linear motion. Looked around at a couple of YouTube videos, and yeah, there were plenty of mechanisms in Thingiverse as well, where it would convert rotational motion, circular motion, into linear motion. But I didn't know if it was a gear in a rack, whether it was a screw gear, worms, bevels, whatever, I didn't know. So I came up with this gear and rack. Had a hard time originally trying to design it in Tinkercad. Tinkercad's got a gear and rack generator, but one of them's in French, and I didn't understand the terminology like modulus and certainly some of the angles, positional angle, and all the rest of this. So I just got a gear and designed the rack myself and put it together, and it works okay, but it's not the best. Printing inaccuracies has been a problem with me. Whenever I've got two parts that I've got to fit together, I have a hard time with that. Even just creating the gear and punching that hole, I did absolutely perfect measurements. It's a 5 millimeter in diameter hole with 2 millimeters cut off to make a flat shaft in the middle. Sent it to the library, got it back. It wouldn't fit. It was too tiny. The hole was just too small. If I tried to sand it down, I wouldn't get a tight fit. So kept playing around and eventually got something to work. And I did that with all the rest of the parts I had to print here. But it was, just a big pain to get what I had designed in Tinkercad to come out printed in the proper dimensions. So I got to play around with that. There was a lot of slop in the rig. Again, probably from inaccurate measurements. If I thought something was just going to be too tight, I would make it too small and have too much slop in there. So I ended up taking 8 pieces of blue painter's tape and lining the inside of that green housing to keep that rack tight and smooth without too much friction. Packaging's an issue. I want to put everything on a board so I can take the whole thing, put it down, and take an image rather than the Arduino, the Raspberry Pi, the long ribbon cable, and all the jumper wires and everything. So still got to package it properly. And then rig calibration. As I described it, you would move the camera and pan it, and move the camera and pan it. But all those numbers are simply hard-coded in my Arduino app right now. It's more complicated to be able to input adjustments to the angles or the spacing or the whatever else you were going to do in Arduino because of that stupid loop that runs continuously. It's not event-driven as much as I would like it to be. I'm also thinking of putting more of the logic in the Raspberry Pi. That's where the camera is anyway. And if I do that, I can control the Raspy Still application, the API, to take a photo when I'm ready to take it, to send a serial signal to the Arduino to adjust something and interrupt it. So I might end up doing all of that as well. But as a prototype, it worked just as I wanted. So now I can take pictures.
Cool.
That's great.
Very cool. Yeah.
Yeah. Nice results.